Welcome one and all, my name is Chris, and I will be your digital tech trainer for this tutorial video. Today's topic is Malware Explained. We will cover 4 main topics today, and a lot of terminology, so fair warning in advance. First up is, what does the term malware mean? Followed by common purposes, who is behind these kind of attacks, and different types of malware threats and their terminology. So get your waders on and let's jump right in. We've got to talk about worms and phishing and a whole lot more. And we'll start with, what does the term malware mean? The word malware comes from the combination of the words malicious and software, and essentially is an umbrella term for any software made specifically to disrupt, damage, or gain unauthorized access to a computer, server, client, computer network, computer peripheral, or other electronic device. By contrast, unintended harm caused by software due to poor code construction, execution, or some other deficiency is usually labeled as a program bug or software bug. A software program can also be considered malware if it secretly performs tasks against the interests of the computer user or the program's intended use. Wikipedia cites one example as the following. At one point, Sony Music compact discs used to install a rootkit on purchasers' computers without authorization, designed to prevent illegal copying, but which also reported on users' listening habits and unintentionally created extra security vulnerabilities. Next, let's focus on some of the common purposes that malware tries to achieve. Originally, malware was coded as experiments by lone individuals or small groups to learn what might happen in given situations. Quickly, it developed into pranks, like the Morris worm, the first U.S. felony under the Computer Fraud and Abuse Act of 1986, wherein Robert Tappan Morris attempted to create a record that he had studied at the Massachusetts Institute of Technology, or MIT. Since personal computers were still in their infancy, these pranks continued with few restraints, eventually taking on more destructive aims. I would suggest paralleling the activities children growing into adolescence might do for each Halloween. Deleting files or operating systems, causing computers to reboot over and over, locking individuals out, or removing accounts from computer systems, and as Hollywood might show, forcing a particular message to appear and being unable to remove it were just some of the dozens of nameless common malware pranks that became more and more destructive and sinister as time went on. As modern home computers became more prevalent, and with the introduction and subsequent spread of broadband internet, malware turned from more destructive pursuits to organized. Malware developers started finding each other anonymously online and sharing information. They developed programs or code together and created a cultural following and forum to try to impress one another. Malware took on a whole new form, frequently designed for turning a profit. These new programs could be targeted at an individual's or organization's computers, with the aim to control them for an illegal purpose. Because these computer owners tend to be unaware, these computers are metaphorically compared to fictional zombies, and therefore called zombie computers. The main form of these attacks were to send spam emails, launch distributed denial of service attacks, DDoS attacks for short, or host illegal websites. Finally, malware growth has evolved into its more prevalent present-day forms, hijacking web browsers to display unsolicited advertisements, generating money by click fraud, pretending a video or website has been viewed a lot for ad revenue, masquerading as legitimate software, either stealing a brand name or fraudulently suggesting they provide a service. Malware can come in the form of taking victims' computers hostage until they pay a fee for its release, embedding Bitcoin miners or other programs unknowingly in web browsers or browser extensions, and of course gaining information such as personal identification numbers or details, email addresses, bank or credit card numbers, passwords, and internet browsing data to sell to a third party or to use for themselves. Of course, malware can be used against businesses and governments as well to steal personal, financial, or business information and gain access to guarded files. Lastly, activists, governments, and militaries can use malware of their own in politically motivated attacks to shut down computer networks, erase files, and in the case of the widely known Stuxnet cyber weapon built by the US and Israel, cause gas centrifuges for separating nuclear material to simply shake themselves apart. Who is behind these kinds of attacks? Realistically, malware perpetrators can be of any age, any demographic, come from any country, or from all walks of life. Most people have some technological know-how or coding skills, but they don't always. There are kits out there that have some malware pretty much set up the way you would need. There are also forums and guides which can help steer you in the direction of a task you wish to perform. Here we're simply going to look at the terminology and where it's heading. The term hacker is well known in TV and film to have negative connotations, yet this wasn't always true. Controversy surrounds this term and its origin, as it originally meant someone messing about with something in a positive sense, that is, using playful cleverness to achieve a goal. However, the meaning of the term shifted over the decades and came to refer to a computer criminal, and the subculture was labeled the computer underground. Film, television, novels, and even console games have hinted at the destructive capabilities of hackers and hacktivist vigilantism, the aims of governments and those that design computer code in terms of loss of privacy and prejudiced control of individuals or crowds, and often link this to violent imagery or with a message that others need to wake up about the dangers of computers. The Ubisoft action-adventure game Watch Dogs, television series Person of Interest, the movie The Matrix from 1999, and the film adaptation of Alan Moore's novel V for Vendetta all highlight these trends, and more. Given a large percentage of the population is not familiar with how computer code works, how software is made, or even some of the basic terminology, many people label those with higher technological talents in computing, regardless of speciality or aim, with blanket terms such as hackers, gurus, geniuses, whiz kids, etc. While some might like these terms, others do not. Computing has a diverse range of skills, from graphic design, networking, and website design, to languages like C++, HTML, Java, PHP, and more. There is both hardware and software components, as well as many different uses and variety of users. Not everyone can fit in one category or under vague terms. There is a resurging trend to set the record straight and redefine the culture, separating the positives from the negatives, and giving recognition to various skill areas. It has been put forward that the term cracker is more appropriate for those who break into computers, whether computer criminals, whom we label black hats, or computer security experts, given the term white hats. By this reckoning, the term hacker is a little outdated. White hats break security for non-malicious reasons, either to test their own security system, perform penetration tests, or vulnerability assessments for a client, or while working for a security company which makes security software. There is certifications for courseware, classes, and online training covering the width of this ethical form of hacking. Black hats, on the other hand, are those who create and disseminate malware, violating computer security, personal privacies, and committing illegal acts for little reason beyond maliciousness or for personal gain. Both these terms, white hat and black hat, were originating from Richard Stallman, an American free software movement activist and programmer. The term gray hats has also been raised. These are considered nebulous in between, someone who might commit an illegal act like hacking into an unauthorized system for the sole purpose of notifying the administrator they have a security defect, or perhaps at the same time offering to fix it for a fee. Other times they might publish the facts to the world instead of any one group of people for good or evil. Finally, we get to the meat and potatoes, or should I say the root of this video, the types of malware threats and their terminology. We'll start with adware. Adware is the name given to programs designed, without your consent, to display advertisements on your computer or device, redirect your search requests to advertising websites, and collect marketing data about you and the types of websites that you visit, so that customized adverts can be displayed. Other than displaying custom advertisements, adware doesn't generally make its presence known. Usually, there will be no signs of the program in your computer's system tray, and no identification in your program menu that files have been installed on your machine. There are two main ways in which adware can get onto your computer: via freeware or shareware programs that you download willingly. Adware can be included within some programs or apps, sometimes as optional, as a legitimate way of generating advertising revenues that help to fund the development and distribution of those freeware or shareware programs. It can also come via infected websites. A visit to an infected website can result in unauthorized installation of adware on your machine. Hacker technologies are often used. For instance, your computer can be penetrated via a web browser vulnerability, and installation is stealthy. Adware programs that work in this way are often called browser hijackers. A backdoor is a malware type that negates normal authentication procedures to access a system. Basically, it circumvents the requirement for a password to log into a system or prevents the encryption of certain data for access. Backdoors are most often used for securing remote access to a computer, i.e. using one computer to control another computer, or obtaining access to plain text in cryptographic systems. From there, it may be used to gain access to privileged information like passwords, corrupt or delete data on hard drives, or transfer information within networks. Perpetrators may also have access to remotely issue system commands and update or download more malware. A bot, short for robot, is an automated program that runs over the internet and is usually utilized to perform repetitive tasks. Alternative names are crawlers, spiders, and web bots, just to name a few. Some bots run automatically, while others only execute commands when they receive specific input, such as a chatbot might warn a user if his or her language is inappropriate. They can be delayed in execution, meaning the source of an infection, website, file download, etc., can be days, weeks, or even months before the bot automatically runs its set task, making it harder to detect their presence. Malicious bots are defined as self-propagating malware that infects its host and connects back to a central server or servers to check in. Often they use this host to reinfect new computers, the server functioning as a command and control center for a botnet, or a network of compromised computers and similar devices. Bots sometimes have the capacity to self-heal, download a new copy, or repair and replace deleted files, if not all the parts of the program are removed. This makes them one of the more serious and harder to remove infections. Bots can complete a wide range of attacks including some of the other methods listed here, and for a broad variety of reasons: gathering passwords, logging keystrokes, obtaining financial information, relaying spam, capturing and analyzing packets or data to and from a computer, launching denial-of-service attacks, opening backdoors on an infected computer, and much more. Bots often make their way onto your computer via social media or email messages that advise clicking a link. The link is often in picture or video form, but may be a URL text link, and often contains other viruses and malware which it uses to break in at the same time. Another typical bot attack comes in the form of scare tactics. Many times a bot will appear as a warning on a web page saying that if you do not click on the associated link, your computer will get a virus. Clicking the link subsequently infects your computer with the bot, as beforehand only the website or ad was infected, not your computer. Here are some potential ways to tell if your computer is infected with a bot. Perhaps your internet access is slow for no apparent reason, or the computer crashes for no apparent reason. Maybe your fan goes into overdrive when the device is idle or not being used. The computer takes a long time to shut down or fails to shut down correctly, sometimes prompting warning messages. Pop-up windows and advertisements appearing even when you aren't using a web browser. Friends and family receiving email messages that you did not send. Maybe your computer programs are just running more slowly. Maybe some settings have been changed, and there's no way that you seem to be able to reverse them. Or your web browser features components you didn't download, such as toolbars, extensions, etc. Here's one topic that most people don't even consider. Click fraud is the act of illegally clicking on pay-per-click or PPC ads to increase site revenue. The ads owners have to purchase more runtime from a host, in this case, or to exhaust advertisers' budgets, again by making them pay more for the same amount of actual sales, that way removing sales competition. This also includes situations like generating fake internet traffic, such as bots inflating the number of views a video receives or the number of subscribers to a YouTube channel. Another example is maliciously attempting to make it look like a publisher is clicking on its own ads, which may cause an advertising network to end its relationship with that publisher. Click fraud is intentional, malicious, and has no potential for the ad to result in a sale, or attempts to have a host pay more for a creator's content. The easiest, least detectable way to commit click fraud is to create a website that hosts banner ads, and click on those ads as much as possible to generate revenue. Some malicious companies will hire low-cost employees, often located abroad, to manually click ads all day long. Others will write or use scripts to automatically click on ads and use malware such as bots to get a victim's computer or device to do the same. Both of these methods are easily traceable unless the user or script masks the computer's true IP address. Next up, denial of service, or DOS, is a basic cyber attack mechanism that prevents a victim from doing business or providing a service by denying them access to their network, server, or customer. It's an attack concept so simple that many different variations have arisen on the single basic theme. A successful denial-of-service attack is a highly noticeable event, impacting an entire online user base, hence a popular weapon of choice for hacktivists, cyber vandals, extortionists, etc. Unlike other kinds of cyber attacks, DOS assaults don't attempt to breach your security perimeter. Rather, they aim to make your website and servers unavailable to legitimate users. DOS can also be used as a smokescreen for other malicious activities elsewhere, and to take down security appliances. In a DOS attack, a perpetrator uses a single internet connection to either exploit a software vulnerability or flood a target with fake requests, usually in an attempt to exhaust server resources such as RAM and CPU, or simply prevent many or any legitimate requests from getting through as time is wasted sorting out the weeds. You might wonder, what might this have to do with you? Well, one common known example uses previously mentioned zombie computers, or slaves, that are distributed across the internet. The distributed denial of service, or DDoS attack, is often launched by bots that have infected the computers of unknowing users. These multi-person, multi-device barrages are generally harder to deflect, mostly due to the sheer volume of devices involved and their varied locations. An eavesdropping attack, also known as sniffing or snooping, is the theft of information as it is transmitted over a network by a computer, smartphone, or another connected device. Typically, eavesdropping attacks are done over an unsecured network, typically public Wi-Fi, focusing on capturing small packets of data that is being transmitted, i.e. sent or received, from one computer or server to another, and reading this stream of small data chunks in search of any type of information useful. This type of network attack is generally one of the most effective when a lack of encryption services are used. Like eavesdropping on someone's conversation in another room, it is typically done secretly or stealthily without alerting anyone and without consent. While financial, personal, or business information may be the target, there is also a booming trade in so-called spouseware, which allows people to eavesdrop on loved ones by tracking their smartphone use. An eavesdropping attack can be difficult to detect because the network transmissions will appear to be operating normally. Eavesdropping attacks can be prevented by using a personal firewall, keeping antivirus software upgraded and up to date, and using a virtual private network or VPN service. Using strong passwords and changing them frequently helps as well. Just don't use the same password for every website. I recommend this website for helping generate new passwords. It's howsecureismypassword.net. I believe here's as good a time as any to throw in an intermission. Stay tuned next episode for the second half of Types of Malware Threats. I'm Chris, and safe journeys.